Hello everyone. The title of this video is Use Logarithmic Models in Applications. Each exercise I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 10.3 titled Evaluate and Graph Logarithmic Functions. And I'm working under the heading Use Logarithmic Models in Applications. I'm only going to be doing the even numbered exercises. Right, so 208, 210, and 212, and that's it for this video, just those three. The odd numbered ones have links to the solutions if you want to look at them. Right, so I'll leave those for you to practice. I will also have timestamps for each of these exercises in the description of the video. So you'll see example 1's timestamp will have the time when I'm beginning exercise 208, example 2 for when I begin 210, and example 3 for when I begin 212. I also request that when I start a new question, pause the video and try to work it out yourself first before watching me doing it and compare. Because if you're just watching me do these things and not practice on your own, chances are you're not going to learn all that much. Alright, so in each of these exercises we're asked to use a logarithmic model to solve. Now, there are only, in this particular section, 10.3 of this text, there are two logarithmic models that we are given to help us solve these application problems. Alright, one is about the decibel level of sound, right, and the intensity of sound, and the other is about the magnitude and intensity of an earthquake. Right. And I'll show you what both of those models are as we get through the questions. Alright, so the first one I'm doing is at top here, exercise 208. We're asked, what is the decibel level of normal conversation with intensity 10 to the negative 6th power watts per square inch? Right. So let me pull this up so you can still see question 208 on the upper left of the screen. Got a piece of paper here that says, example 1, number 208. The model we're using here, and I've already written this out, is this model on the decibel level of sound. And again, this is given to you in that textbook in section 10.3. And it's the following equation. D equals 10 times the logarithm base 10. Right, remember, when there's no base in this text, it's base 10. So D equals 10 times the logarithm of I divided by 10 to the negative 12th power, where D, on the left side of the equation, represents the loudness level in decibels, and I, right, that's inside the logarithm here, with this 10 to the negative 12th power, I represents the intensity of the sound measured in watts per square inch. Alright, so in this first problem, we're given the intensity. Right, in question 1, we're given that the intensity of the sound of this normal conversation, I, equals 10 to the negative 6th power, watts per square inch. Let's put squa in, right, square inch. So this is going to replace I in the formula, and then I solve for D, and it's very, very simple. So let me make this a little larger. So yeah, so I'm just going into the formula, So D, right, the decibel level of the sound, the loudness level, will be equal to 10 times the log base 10 of, and then I is being replaced by the intensity, right? This is 10 to the negative 6th in the numerator, right? Divided by 10 to the negative 12th is always in the denominator there. All right, and then we simplify this. Right. So this is 10 times the log base 10 of, now remember properties of exponents. 10 to the negative 6 divided by 10 to the negative 12th would be 10 to the negative 6 minus negative 12, which would be negative 6 plus 12, which would be positive 6. So this is 10 times, and then the log base 10 of 10 to the 6th would just be 6. Remember what the logarithm is. Logarithms are exponents. This is, what power would I need to raise 10 to get 10 to the 6th power? Well, it's right there, the 6th power. So this is 10 times 6, or 60. So the value of D in this particular problem is 10 times 6, 60 decibels. And that's all they want. That's the decibel level of normal conversation with an intensity of 10 to the negative 6 watts per square inch. And there you go. The decibel level of normal conversation, if you want to write that out with that intensity. Okay, great. But yeah, so I didn't have this memorized. This is like a physics thing, but it is a model, a physics model, where a logarithm is used. So that is why it is introduced in this section on logarithmic functions. All right, now we'll use this again in the next question as well. All right, the next question I'm going to do is number 210. So it's another one about sound and decibel levels and all this. And it's the same problem basically, just with a different intensity, and it's not about a normal conversation. It's about a motorcycle. Right? So what is the decibel level of the noise from a motorcycle with intensity of 10 to the negative 2 watts per square inch? All right, so once again, let me pull this up, so you can see the problem till you can still see number 210. Keeping the same model, right? Now this is number 2. Right? Same model, right? The decibel level of sound. D equals 10 times the log base 10 of I divided by 10 to the negative 12th power. Where again, D is the loudness level in decibels, and I represents that intensity of the sound in watts per square inch. And again, that's what we were given. Right? We're given I. They said this motorcycle noise has an intensity of 10 to the negative 2 watts per square inch. I'll just do this now, watts per square inch, like that. Alright, and make that a little bigger again. Because now we're just plugging this in for I and finding D, right? So D, right, the decibel level of that sound, is 10 times the log base 10 of the intensity, which is 10 to the negative 2 watts per square inch, divided by 10 to the negative 12. So this is 10 times the log base 10. Now 10 to the negative 2 divided by 10 to the negative 12 would be 10 to the 10th power, 10 to the positive 10 power. Right, negative 2 minus negative 12, or negative 2 plus 12. So this is end up 10 times 10. Right? Again, very simply, this is what power do I need to raise 10 to to get 10 to the 10th power? Well, it's right there, the 10th power. Right, so this is just 10 times 10, or 100. So D here equals 10 times 10, 100 decibels. And this is the level of sound for this noise of a motorcycle with that intensity, right? That 10 to the negative 2 watts per square inch intensity. There's the decibel level of the noise from the motorcycle, 100 decibels. Right? Very, very simple. Right? Just, again, all you need to know is what model is being used, and again, this is given to us in that section. Alright, and then my final question that I'm going to cover here, number 212. This is about earthquake intensity. Right, so a totally different model, right? Not the decibel level of sound model, but there's another earthquake intensity model that is again given to you in the section. If you go back and read through this section 10.3, you'll see it. So in 2014, Chile experienced an intense earthquake with a magnitude of 8.2 on the Richter scale. In 2010, Haiti also experienced an intense earthquake, which measured 7.0 on the Richter scale. Compare the intensities of the two earthquakes. Right, compare the intensities of the two earthquakes. Alright, so again I'm going to pull up so you can see the problem still. Right? You can still see number 212 in the upper left corner here. Got number 3, right, example 212. This is the model we're being asked to use now. Right, and again, I've written it out. It's on earthquake intensity model. Right. Sorry, something popped up on the screen up there. Alright, so here it is, the earthquake intensity model. R equals the log base 10, again in this text when there's no base on the logarithm, it's base 10, the common logarithm. R equals the log base 10 of I. Very simple equation, where R is the magnitude of the earthquake, right? This is that on the Richter scale, that number that comes up on the Richter scale. And I is the intensity of its shock wave, right? Or just the intensity of the earthquake. Right? Now we are given two magnitudes here, and we're asked to compare their intensities. So we're going to be solving for intensity here. So what we're given in this problem is R, well, I'll call it R Chile. R with a subscript of Chile. Right. The Chilean earthquake had a magnitude, right? The value of R is the magnitude of 8.2 on the Richter scale. And separate from that, the Haitian earthquake, which I'll call R sub Haiti, or you could go R sub C, R sub H if you want less writing. The magnitude R for the Haitian earthquake was given at 7.0. And we're asked to compare the intensities of these two earthquakes. Alright. So let me make this a little bigger. So yeah, that's what I'm going to do. Right? We have R equals the log of I, where I is the intensity. Right? I is the intensity of the shock wave, intensity of the earthquake. So I'll keep the formula up. And we're going to first find the intensities so we can compare them. The intensities of the earthquakes. So for Chile, so we have, all right, so let's do Chile, sorry. So R for Chile is equal to, again, the log base 10 of I. I'm going to write the formula again. And R for Chile, the intensity of the Chilean earthquake was 8.2. Right, so we have 8.2 equals the log of I. And then we solve for I. Remember how to do that. Solve a basic logarithmic equation. We can change to its equivalent exponential form. Remember, this is base 10, so the intensity, I, and I'll put like a subscript of Chile here again, the intensity of the Chilean earthquake was 10 to the 8.2 power. And whatever units intensity is given in. But here's the intensity of the Chilean earthquake, 10 to the 8.2 power. And then I do the same for the Haitian earthquake. So let me get this out of here. I'll lower it a little bit. Right, so for the Haitian earthquake, again, same formula, right? The magnitude of the earthquake is equal to the log base 10 of the intensity of the earthquake. The magnitude was given to us. They said it had a magnitude of 7.0 on the Richter scale, right? So 7.0, or just 7 over here on the left side, equals the log of the intensity. And then once again, I can solve for I very easily. Change this to its equivalent exponential form, and we get the intensity of the Haitian earthquake, right, I Haiti, will equal 10 to the 7th power, right? 10 to the 7th power, or 7.0 if you want to write that as they gave it to us. Alright, so maybe you can see that, the intensity of the Chilean earthquake is bigger, right? They both have the same base, right? They're both base 10. And, because the base is bigger than 1, remember, base bigger than 1, exponential functions with bases bigger than 1 are increasing. So 10 to the 7th is going to be smaller than 10 to the 8.2. Right, so 10 to the 8.2 power is greater than 10 to the 7.0, right? So one thing we could say is that the Chilean earthquake was more intense than the Haitian earthquake. Right, but that's not that interesting to say that, because you could have told me that from their magnitudes. Right? I mean, the magnitude of the Chilean earthquake came up at 8.2 on the Richter scale, but the Haitian one was at 7. You could have told me that the Chilean one was more intense from that number alone. Right? So this isn't very interesting to say. Rather, I would rather say how much more intense, how many times more intense was the Chilean earthquake? Let me ask that question, right? So how many times more intense was the Chilean earthquake? All right, so let's take their ratio. All right, let's take the ratio of these. Take the intensity of the Chilean earthquake and divide it by the intensity of the Haitian earthquake. And see what we get. That's 10 to the 8.2 divided by 10 to the 7.0. Right, that's 10 to the 1.2 power. which if I go to a calculator, let me pull up, I got a TI-84 here, 10 to the 1.2 power is about 16 if I go to the nearest whole number. About 16. So that tells me, right, again, this is approximately 16. So the second thing I can say, and this is a little more interesting because it has a number involved, the Chilean earthquake was about 16 times more intense than the Haitian earthquake. Right, the Chilean quake, I'll just say quake, right, save I'm writing. The Chilean quake was about 16 times more intense. Okay, than the Haitian earthquake. And that's more interesting to say. Right, it actually has some number involved, has a little bit more meaning. Because again, this first one you could have just said, oh yeah, the Richter reading for Chile was higher than the Richter rating, the magnitude for Haiti. So you could have said this, right away. You could have said the Chilean earthquake was more intense than the Haitian earthquake. A more interesting question would have been how many times more, right? By what number is the intent? How much more powerful? How much more intense was the Chilean quake? About 16 times more intense. Right, so that'll involve doing a ratio, right? Take the larger intensity divided by the smaller intensity, and you can tell how many times more intense one earthquake was than the other. All right, and I hope that makes sense. Wonderful. All right, so that's it. That's all I got. All right, just a couple examples where I'm using that decibel level of sound model, and the one example here where we used the earthquake intensity model, but we used it twice, right? With Chile and Haiti. So either way, we used both models that we were introduced to in this section two times. And I'm hoping that watching me do these three questions here with the decibel level of sound model and the earthquake intensity model, help you out if you're ever asked similar questions, about sound intensity or earthquake intensity. And thank you very much for watching.